Good morning. I am Ratna Priya, Assistant Professor, Department of Electronics and Communication Engineering, Dr. MGR Educational and Research Institute, University. So today we will be discussing about the topic multiplexer in digital electronics. Multiplexer. So multiplexer, it is nothing but it is a combinational logic circuit and which is also called as a data selector. It will be having so many inputs and one output, that is many input lines or multiple input lines and one output. How the one output will be selected? So it is selected by the selection lines. So if you are having multiple inputs like I0, I1, I2 and I3, any one will be reflected at the output side depending upon the selection lines. So for example, we can take this, that is you can play a sound system, you can play a sound using MP3 player or a digital phone or a satellite or a digital cable TV. Any one of it will be selected using the mux and it will be reflected in your output, that is in the sound system. So there were so many multiplexers available. So first one is a 2x1 multiplexer. So 2x1 multiplexer means you will be having n selection lines, means if you are having n selection lines, then you will be having 2 power n input lines. Say suppose I am having one selection line, then 2 power 1 it is 2 input lines I will be having. So for a 2x1 multiplexer, I will be having 2 input lines with one selection line. So I will be having only one selection line to select whether it is, that is say suppose I0 and I1. I will be having only one selection line to select the output. Say suppose my selection is high, that is 1. My selection is high means let us assume that I0 will be reflected in the output. If my selection is 0, then I1 will be reflected in the output. So depending upon the selection, that is 2x1 means 2 inputs and 1 selection line. The selection line, if it is high means I0 will be reflected in the output, and it is low means I1 will be reflected in the output side. So the symbol for multiplexer is like this, that is n selection lines, I0, I1, I2, then IN, and here also SN, S0, and then this is my output. So this is the symbol for multiplexer. MUX is the short form, and this shape it is called as the wedge shaped. It is a wedge shaped symbol. Next one is a 4x1 multiplexer. So it means it has 4 inputs and 1 output. It will be having 2 selection lines, S1 and S0. So all the inputs are going into the multiplexer and this is my output Y. So how to select? So S1, S0. So these are my inputs and my output is Y. So if it is 2 inputs means we will be having 4 combinations, 0, 0, 0, 1, 1, 0 and 1, 1. So if it is 0, 0 means A0 will be selected, 0, 1 means A1 will be selected, 1, 0 means A2 and 1, 1 means A3. So with this truth table, your 4x1 multiplexer will work. So this is these are the selection lines which select which input has to be reflected at the output side. Now we will implement the same 4x1 multiplexer using logic gates. So the same truth table, S1, S0 and Y 0 0 0 1 1 0 1 1 A0 A1 A2 and A3. So for this we are going to develop the 4x1 multiplexer using logic gates. So for S1 I am drawing a line, and for S1 bar I am using a NOT gate. So this is S1 bar and this is S0, and to get the complement of S0 I am using a NOT gate. And then so for A0 output S1 and S0 should be 0. So this means it is high. So when it enters into the NOT gate it is 0. So 0, S0 is 0 and S1 is also 0 and A0. When I am having this input I will be getting the output. So this is my first one, that is A0. And next one for A1. A1, S1 is 0. So S1 is 0 and S0 is 1 and A1. Put together, putting into a AND gate. And then third combination is S1 and S0 bar, then A2. So this is my third combination. And fourth one, S0 and S1 both are 1. S0, S1 and S0, then A3. And then put together everything into a OR gate. So in this way you can implement your multiplexer. So this is my output Y. So what is my Y? My Y it is equal to nothing but S1 bar, S0 bar into A0. So for this implementation I am using this AND gate, and then plus S1 bar, S0, A1 plus S1, S0 bar, A2 plus S1, S0, A3. So this is the function we have implemented using this logic gates, 4x1 multiplexer. Now we will see an example for this multiplexer design. So implement the Boolean function. Implement the Boolean function. Summation m, which is equal to 1, 3, 5 and 6. See here, this function I am going to implement in this using the multiplexer. So 1, 3, 5 and 6. So this means it is having 1, 3, 5 and 6 were the outputs of this Boolean function. So we will be having a minimum of 8 input variable over here. So we have to use, first we are going to use this with 8x1 multiplexer. So how to do? So D0, D1, D2, D3, D4, D5, D6 and D7. So to implement the 8x1 multiplexer, we will be having 3 selection lines, right? So 3 selection lines, 2 power 3, then 8 outputs. So S2, S1 and S0. So everything it is getting into the multiplexer. And I will be having only one output as Y or F, whatever maybe it is, Y. So we can write like, so the truth table, S2, S1 and S0. So I am writing here min terms I am marking here, and Y, output is Y. So this is selection lines and this is my output. So 3 inputs means I will be having 8 combinations, 0 0 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. So here it is 0 1 2 3 4 5 6 and 7. So what is given in the question? It is 1 3 5 and 6 were the midterms. So for 1 it is 1. 1 it is 1, 3 it is 1 and 5 it is 1 and 6 it is 1. So rest were 0. So rest were 0. So Here if you see, it is very simple. So D1, D3, D5 and D6. D1, D3, D5 and D6. So all put together you have to connect it to 1. And all other min terms is 0. So 0, 0, 2, then 4, then 7. So 2 0. So in this way you can implement or you can design a multiplexer. So these are our min terms 1, 3, 5 and 6. So we have developed the truth table and with that we have designed the multiplexer. Next we will be seeing same thing, the same min terms you are going to implement using 4 cross 1 multiplexer. How to design the same min terms using 4 cross 1 multiplexer? Why 4 cross 1 multiplexer is not used? Because it is having 1 to 6. That means it is having 7 terms. So you can't implement it using a 4 cross 1 multiplexer. But how to design using a 4 cross 1 multiplexer? So 4 cross 1 multiplexer means you will be having only 4 inputs, right? 4 inputs with 2 selection lines. So yes, no, yes, 1 and yes, not. So here you will be having, say suppose I am writing D0, D1, D2 and D3. So I will be having only these 3 inputs, these 4 inputs and my output is Y. So how to design using 4 cross 1 multiplexer? See, D0, D0, D1, D2 and D3. See here you have to use the same rule. This is A bar and this is A. See what is our terms? This is 1, 0, 1, 2, 3, 4, 5, 6 and then 7. See what is our min terms? 1, 3, 5 and 6. So circle those terms 1, 3, 5 and 6. So this is the rule. So what is our min terms? You have to circle those. So now you have to check each column. See here nothing is circled. No circle is there. 0 and 4 both are not circled. So it is 0. And here if you see both are circled. Both the terms were circled. 1 is circled and 5 is circled. So for this you have to take it as 1. So these are all rules. And here if you see 2 is not circled and in the bottom row 6 is circled. So which is circled you have to write that. So you have to write this as A. A. And in the last column A bar is circled and A is not circled. So you have to write here A bar. So this is our combination. See here for D0 it is 0. So what is our D0? D0 you have to give it to 0. D1 it is 1. So D1 it is 1 or else we will write like this. D0 it is 0. D0 it is 0 and D1 it is 1. And what is D2? D2 it is A. And what is our D3? D3 is A bar. So in this way you can implement with using 4 cross 1 multiplexer. If you are having so many terms also you can do. Similarly we can implement these functions, that is like if you want 8 cross 1 or anything you can implement, or 16 cross 1 multiplexer you can implement it also using 4 cross 1 mux. 2 4 cross 1 multiplexers you can implement. Whatever may be the function is, we can design it with the minimum multiplexer configurations. Thank you.